Let's come up with the general form for the Laplace of sine t, which will be also useful for situations where our angle is expressed other than t, like 5t, 2t, negative 3t, and so on and so forth. We are going to come up with general form following the formula for Laplace transform. So this would mean this is the Laplace transform of sine t can be expressed in this manner. The formula, the integral of 0 to infinity of e to the power of negative st, and your f of t now is sine of t dt. So from here, we need to come up with a situation or a process which allow us to integrate this. Now, if you're thinking about integration by parts, yes, you can do this by first thinking that sine t would be your u. That would mean e to the power of negative st dt would be your du, and you will have your form of uv minus v du from this form. However, once you reach that, this sign later on will result to a cosine, and you will need another integration which will also return to sine again. It will just be alternating in its appearance. In short, we cannot come up with the exact form of this. That is why there is a formula for integration. If we have a situation where we have e to the power of at, alpha t rather, where alpha is any value, and then sine of beta t, whether or not b is 1 or any value, dt. This is just equal to this form, e to the power of alpha t times alpha sine of bt. Then you have here minus b cosine of bt all over alpha squared plus beta squared. This is actually a formula in our calculus, and we were able to have that as part of a discussion if you have an integral of an exponential function e together with a trigonometric function, which you cannot use the integration by parts in any other method. So with this now, our alpha here is negative s as indicated by this, and of course our beta is just 1 because beta t is not beta t or beta is just 1 here. In short, this will just be equivalent to this form, integral, no longer integral, but you are going to actually come up with this. But take note that your integral has the endpoints or the interval 0 to infinity. So this will become e to the power of your alpha, which is negative st, times negative s as your alpha again. Take note of this formula. Okay, please be guided with that. Sine of beta, which is 1 t, minus your beta is also 1, cosine of beta t, all over alpha squared, or since it's alpha, you have the square of negative s plus the square of 1. This is integrated 0 to infinity. And again, the 0 to infinity talks about the value of t. Okay? So moving forward, e to the power of negative st, and you will have here again negative s sine t minus cosine t over s squared plus 1. Okay? S squared plus 1. This can be moved to the denominator having a negative exponent. So in the numerator, you will have negative s. Again, this is 0 to infinity. S sine t minus cosine t over e to the power of positive st now times s squared plus 1. We're doing this because there is a unique relationship that as t approaches infinity, this expression where t is one of the exponents, e to the st will approach to, not e to the power of st, I'm sorry about that. It's 1 over e to the power of st, as this is found in the denominator, it all approaches to 0. So with that, for the first substitution, the entire expression will become, since this can be written as 1 over this, let me rewrite this as 1 over e to the power of st times negative s sine of t minus cosine of t over s squared plus 1. This will approach to 0 when you have infinity, okay, as your first substitution. So your first value here is 0. Then for 0 substitution, You will have here minus 1 over e to the power of s times 0. Okay? Then you will have here times negative s sine of 0. Okay, sine of 0, okay? Sine of 0 minus cosine of 0 as an angle over s squared plus 1. Okay, so this will become negative 1 over 1, as this is over is just 1, so we can just simply write that as negative 1 times, take note that for here you also have negative s sine of 0 is just actually equal to 0, right? Sine of 0 minus cosine of 0, which is 1, all over s squared plus 1. So by double negative property, that's positive s. Sorry, that's not positive s, because it becomes 0 here. So 0, this will become plus 1 over s squared plus 1. So generally, you will have 1 over s squared plus 1 for your Laplace transform of sine t. Okay, this is now the form for your sine t. As for a short generalization, we will have that a separate video where we have to apply another angle aside from t. Again, this is 1 over s squared plus 1. Thank you very much for watching.